Section is 12.2, which is graphing systems of linear inequalities. So it's kind of combining a couple things that we've done. So we've obviously been working a lot on graphing systems of linear equations. And that's where we graph the two lines and then figure out where those two lines intersect. And then going back to last semester, we talked about just graphing linear inequalities. So now we're going to combine that and graph linear systems. So we're going to start off by reviewing just how to graph a linear inequality. So looking at our first example, remember we graph these exactly like we graph lines. There's just a couple differences at the end. So we're going to start with placing our y-intercept at -2. And then from there, our slope is up 1 over 2. Up 1 over 2, and you could also go in the opposite direction. Okay, so now that I have my, outline of the line, we then have to decide what type of line it will be. So remember, if you have an equal to, less than, or greater than, it's going to be a solid line. But if you just have less than or greater than and it's not equal to, then it's going to be a dashed line. So according to the inequality sign, this will be a solid line. The next thing we have to decide is the shading. So because it's greater than, that means that everything that is greater than the line is going to make it true. So remember, when we graph just regular equations, regular lines, the solution is on the line. But in this case, the solution is on the line, but also anything greater than that line. Okay, let's go ahead and practice another one. So this one we want to start at 1 because that's what our y-intercept is. And then this time our slope is 3/2. So we're going to go up 3 and then over 2. And then we could also go in the opposite direction as well. Because the sign is just a less than symbol, we are going to do just a dashed line showing that the solution is actually not on the line. And then based on the sign, it says it's less than. We want to shade everything that is less than, so everything that is below. Okay, so hopefully that's kind of coming back to us. So this was technically a review, and now we're going to get to the new stuff. So when we graph a system of linear inequalities, we're going to do it the same way, but we're just graphing two. Now keep in mind, when we are just graphing linear equations, we're figuring out exactly where they intersect. But with these, it's a little bit more complicated because the solution isn't where they intersect. The solution is actually where it's shaded. So if we're shading two lines, we're going to find where they share a common shaded area. Okay, so let's go ahead and start with this one. So we're going to go ahead and put this in y-intercept form, which means I'm going to subtract that 6x. So we'll have 3y is less than or equal to -6x plus 12. So I just subtracted the 6x. From there, I'm going to divide everything by 3. So I'd have y is less than or equal to, we have -6 divided by 3, which would be -2x. And then we have 12 divided by 3, which would be 4. So that's one of my lines. And then obviously the other line is already in slope-intercept form, so we don't have to do anything to it. All right, so we'll start with graphing our first inequality. So the y-intercept is at 4, so we'll start with a point at 4. From there, our slope is -2, so we are going to go down 2 over 1 and down 2 over 1. Now, because it has an equal to symbol, that tells us that this is going to be a solid line, so we will go ahead and graph it with a solid line. Now, if you do have a couple, some students like to use colored pencils or highlighters. Obviously, pencil is fine too, and you can just lightly shade. I'm going to use a highlighter. So because it's less than or equal to, I'm going to shade everything that is on the smaller side because it's less than. Okay, now I'm going to go back and graph the other inequality. So for this one, I'm going to start at -3, and then from there, my slope is -1/2. So I can go down 1 over 2, or I can go in the opposite direction. Because the symbol is just a greater than and it's not equal to, we know that this is going to be a dashed line. And then our last step is the shading. So this time it is greater than, so we want to shade everything above. So obviously you'll notice that there is some overlap there. So this gets a little bit messy, but the answer is everything that's inside here. So anything that is inside, I usually call it the blob. Anything that's inside the blob is actually going to be a solution. Okay, so again, with linear equations, it's just that point where they cross, but for this, it's a little bit more complicated because there are several solutions. Okay, so let's keep going. We're going to try another example. So we'll start it the same way. So I have to get this into slope-intercept form. It's very close, but we just need to subtract that 3x. So I'm going to get -3x plus 1. So that equation is ready to go. And then the second one is also already ready because it is in slope-intercept form. All right, so we will go ahead and graph these. So for the first one, I start at 1 since that's my y-intercept. And from there, I go down 3 over 1. And I could also go in the opposite direction. Because it's an equal to symbol, I know I'm going to do a solid line. And then next I have to do my shading. So because it says it's less than or equal to, we want to do everything below the line. So now that's done. Okay, let's go ahead and graph the next line. So for this line, we want to start at -2. And then from there, we're going to go up 2 over 3, up 2 over 3. And you could also go in the opposite direction, down 2 over 3. Now this one is going to be a dashed line because it is just greater than. And then also because it is greater than, we want to shade above. So we're going to go ahead and shade above the line, so everything here. So you can see where they cross is where the answer would be. So again, this is going to look really messy, but all of this stuff, all of those bright colors, is where the answer is. Okay. So just we're going to look briefly at these special cases. So a lot of people get confused because they say, oh, I thought when it's parallel, it's automatically no solution. Now that's the case for equations, but it's not the case for inequalities. So for inequalities, if we were to shade these, let's say this top one, it was everything less than. So we shade below, right? But now let's say for this bottom line, it was everything greater than, so we shade above. So technically that middle space is where the solution is. So even though they're parallel lines, it still has a solution. Okay, now let's look at another case of parallel lines. Let's say the top line is greater than, so we have to shade everything above. And then the bottom line is less than, so we have to shade everything below. Now this would be a case where there is no solution. So the idea that you should be gathering from this is just because it's parallel lines doesn't mean it's no solution for inequalities. So you will need to shade so you can figure out, am I shading in opposite directions or am I shading inwards? And then this last thing is in the book that we are doing in class. So that gives you an overview of 12.2.